It's me, Paulos, Raheb, and Bernardo in this group. And first we will present our research topics, then how we address sustainable development goals and how we contribute to research utilization at the end. First, I will try to explain in simple diagrams my research topic and what I am working on. If you see on the top, there are 3 collaboration models. When you think of any construction project, there are 3 parties that work on any project. The client, in this E39 case, Statens vegvesen is the client, and the contractor is the other C, and the consultant. So we call them the 3 Cs. So there are 2 traditional models of working, how these parties collaborate and work together. The first one is when the client is the contractor itself and the designer itself. It was like that some years ago in Statens vegvesen. And the current traditional model is like this. There are contractors, designers, and clients. So they don't really work together. They have their own strong boundary and they don't collaborate. So in the future, it should be more collaboration. They should have their own boundaries, but also work together. For example, in this E39 project, it's impossible to have optimal solution, develop optimal solution if there is no collaboration. So it's not only that. When we see projects, this is a timeline for a project, start with planning and design, and end up with project execution. And there is also operation maintenance of projects afterward. Traditionally, contractors involve only to develop, to deliver only the project. And this makes them to think only in one side of their brain. They don't use their both sides. They just think about making profit from the execution phase. So in the future, it should be more involvement of the contractors in the planning and design phase of the project, together with collaboration models. There should also be collaboration between the client and the designer to develop optimal solution. So basically, I am working to develop such kind of collaboration models and early contractor involvement approaches. There are several models that can be used to achieve this. So I'm studying this in detail.
Hello. Me and Statens vegvesen, together with Antenu, are working on this research project on dynamic buckling and parametric excitation of the curved bridge, the curved floating bridge solution for Bjørnafjorden. So buckling, when seen as a static problem, will decrease the resistance of a structure when it's subjected to compression loads as opposed to tension loads. We see a column buckling, we see a simple arc buckling, and there is well-established criteria already in the codes, in the Euro codes, how to design structures safely for the static scenario. But for our bridge, we have to look at it dynamically. We will have wind, waves, and currents, and climate change, for instance. We have to take into account that more extreme events can occur more frequently in the future, and we have to take into an input for these forces. These forces will vary in time and space. I mean, the distribution along the bridge, how they act on the bridge, and this will lead to variable actual forces on the bridge itself. This, in turn, will lead to a loss of stiffness, since the buckling can be seen as a loss of stiffness. And we are trying to come up with a criteria to limit, for instance, the variance of this stiffness, so that we keep the bridge safe. Or, in other words, we're trying to avoid a very unsustainable event.
So, my project is about ice fair roads. As you can see from the pictures, we would like to harvest solar energy during summer, save it in some type of storage, and then reuse the energy again during winter for anti-icing the road surface. So generally in project, I investigated two types of the different storage. First, the vertical ground storage, which consists of a boreholes, which almost the depth of 30 to 200 meters. And also the horizontal ground storage, which almost a pipe networks located in a shallow depths of 1 or 2 meters. Based on this investigation, we found that both systems are almost working, but the vertical ground heat exchanger, the left side, are more efficient, but absolutely the horizontal ground heat exchanger, the right picture, are almost cheaper. So if we want to say that sustainable development goals for these three projects, which me, Bernardo and Paulos explains, we reach three main goals, including affordable and clean energy, industrial environments and infrastructure, and sustainable cities and communities. For the first one, affordable and clean energy, for example, for my project, we found that we are going to use solar energy as a renewable energy. Or for the Paulos project, we found that having a better contract for using a clean energy from scratch can help huge. Can make it more easy to reach this goal. For the industry, innovation and infrastructure, so my project has a goal to reach forever ice-free roads. Bernardo's project has goal to make a resilience infrastructure, and absolutely Paulos' goals, which is a contract, can help a lot to reach to control the life cycle costs. And the last one, the sustainable cities, is very important as well. For example, safe and durable connection between cities is the Paulos' goal. To reduction distribution of salt and sand for anti-icing the road surface, which make the cities or make the environments both on the land and under the water polluted is my goal. And also making more sustainable communities or construction from scratch is Paul's goals.
When we come back to research utilization, we put it in three levels. The client and the suppliers are the main actors, and this is how they communicate. First, the client can utilize researches by putting needs or putting requirements. When the client knows that there are new way of doing things or innovative way of doing this, then the client put it as a requirement for new projects. Then it's possible to connect to research utilization. And design criteria. If you see, for example, Bernardo's project, he is working on finding or improving design criteria, so that the consultants will use these criteria when they design the new projects. So it's how research can contribute to design criteria. And contract standards and handbooks are developed by Statens vegvesen, and in order to guide suppliers how they should design things and how should they develop things. So our work connected directly with design criteria, contracts, standards, and handbooks, and it helps suppliers to work to fulfill these requirements. When they look for new solutions, they go to research and find the new way of doing things to fulfill the client needs. So this is how we connect the research utilization generally. Thank you for your attention. That's all.